Hello, good morning to all. Very good morning, guys.
Hello, sir.
Are
Good
you?
morning.
Good
Very good
morning,
morning.
sir.
Very good morning. Who didn't join
Sir,
yet?
can you hear me? Clearly?
Yes, yes, yes. Agatha didn't join, and
Uh, she said like I'm joining, but sir is not letting me in like that.
uh, not like that. I didn't have any picture to stop any other. Tell her to join back again.
Okay, sir.
And Agatha and one more. Agatha and one more student is saying. Okay, we'll leave that everything. We'll start that class. So where were we? We were doing linear equation, no? Yes or no? Okay. So today we'll start the linear equation in put a heading.
Sir, I have
Linear.
some doubts on the linear equation. But
Yes, you have doubt. So please ask me.
so 1 minute.
Yeah. Get in the camera, everyone, please. Abraham, David, Jacqueline, obey the camera. So
So can we like just do any one of the word problems?
okay. So I'll do one of the word control. This very hard. So that
Morning, sir. Sorry I was late. I was joining, but I couldn't like get in.
I'll do this question. Who didn't join? One student is missing. Okay. So it is written the length of a rectangle is twice its breadth. Its perimeter of a rectangle is 66 centimeters. Find its length and breadth. Okay.
Sir,
So yeah,
how many questions did you do so far? I couldn't see the previous questions we were doing.
we did linear equation in one variable. All the word problems. So like for 5.4 we have done. Today we will start the next after the 5.4.
Okay.
Okay. So now it is given the length of a rectangle is twice its breadth. So like we don't know the length of the rectangle, so I will take length as L. Okay. So I will take length as L. So let length of a rectangle be L. And the breadth, I don't know, so I will take the breadth of a rectangle be B. Now what is given? The length of a rectangle is twice. So Miraculin, how will you make this equation? The length of a rectangle is twice. How will you make this equation? Yes, Miraculin.
2x. 2x, sir.
I didn't take any x. I didn't. I take breadth as b and length as l. So I will get l is equals to 2b because the breadth is b, no? That's what it is.
Yeah.
Okay. So if perimeter of a rectangle is 66 centimeter. Now what is the formula for the perimeter? So perimeter
L plus B.
formula 2 into L plus B, not L plus B, 2 into L. So now L is written, can I write instead of L as 2B here?
Yeah.
It will become 2 into 2b
2 plus b.
plus b. Okay, so perimeter is given 66.
Yeah.
Okay, so 66 is equals to 2 into 3b.
3b
Now this
equals
2
to
will multiply.
60. Yeah. Then 6b equals to 66. And we
And
will
then,
divide it with 6.
yes, so what will you get? 11 as b.
11.
So means the breadth is 11 centimeters. Now if I will put here, so I will get length as 2
22.
into 11. Yes, the length will be 22 centimeters.
I
Got it?
I did this sum like
Two into
the answer
L
was
plus
correct,
B.
but
Yes. Say one by one. Miracle, what you're saying?
like I did the question correct, but the problem was like you wrote 2b, but I write 2x breadth
Okay,
because
that is
there was
also correct.
twice.
That is also correct. No problem. Yes, wait, what you're saying?
But how do you make like 2 into L plus B?
This is the formula for the perimeter of a rectangle, na? What is the perimeter of rectangle?
66.
No. The formula I'm asking. What is the perimeter of a rectangle in formula? The formula is 2 into L plus B. This is the formula for the perimeter of a rectangle. Okay. So then in that L, I put 2b here because they both are equal. So 2b plus b will become 3b, like that. Got it? Say yes or no?
Okay, so yes.
Got it?
Yes, I got it.
Okay. Turn on the camera, everyone. Abraham, are you there? David, please turn on the camera. Okay, now put a heading. Linear equation in two variables. Linear equation in two variables. So now what do you mean by linear equation? Linear equation is the equation in which the degree of polynomial is 1. That is called as what? Linear equation. Now what do you mean by linear equation in two variables? The linear equation in two variable means when two variables are there. Okay. So for example, if I will write x plus y minus 7 is equals to 0. Now, in this case, how many variables are there, Nayantara? Two variables are there, 1 and 2. Hence, it is called as linear equation in two variables. Because two different variables are there, it is called as linear equation in two variables. Are you getting this, everyone? Say yes or no? Hmm? Now, I will ask this question from Agatha. Agatha, this is linear equation in one variable or linear equation in two variables?
One variable.
One variable. Miracle, this is linear equation in one variable or this is linear equation in two variables?
One variable.
In this the second one I'm saying, this one.
Two variables.
Yeah, 1 and 2. Two variables are there, hence it's called a linear equation in two variables. Got it? Now, if I will ask this question from David. David, what will I put in place of x to get the answer as 0? What will you do? What is the value of x you will put in this equation so that you can get answer as 0?
X is equal to
X is equals to 2? Yes?
yes. Yeah.
Okay. But here, can you put any other value other than x is equals to 2? Can you take any other value? When you will put, you will get answer as 0.
No.
Any value in the number system. We have infinite number system is there. So can you put any number? Anybody can answer in this. Like
Two,
any
sir?
other number, yeah, 2 is there. 2 number is there, but any number other than 2.
Because like 2 minus 2 equals to 0. So
That is correct. We got 2. But any other number than 2?
In the next one, x plus y equals to.
No. In this one only.
Um,
Other than 2, any other number is there? Can you think out of the box?
no.
Not at all, because there is no number. Why? The reason behind it is that this equation is linear equation in one variable. And linear equation in one variable has only one solution. And this is the solution for this equation. Okay? Listen everyone. Linear equation in one variable has only one solution. Has only what? One solution, not more than one. Means x is equals to 2, x is equals to 2. Are you getting this? Say yes or no. Everyone got this? Say yes or no. This is linear equation in one variable. But if I will talk about this, Nayantara, what will you get x and y? What will you think to put the value of x and y so that you can get answer as 2?
1.
Like x is equals to 1 and y is equals to 1?
That wouldn't be there because both are different variables.
Yeah, it's okay. Even though different variables are there, they can have same value. It's okay. So you can take x is equals to 1 and y is equals to 1. So if I will write in the form of x comma y, so first is when you will take 1 comma 1. It means x is equals to 1 and y is equals to 1. Any other number, David, that you are thinking to take any value of x and y? Quickly unmute your mic.
No.
No? I am thinking.
Can I say?
Yes?
2 and 0, 2 plus 0 equals to 2.
Means 2 comma 0 because
Yeah.
x can be as 2 and y can be as 0.
Yeah.
And we call 2 comma 0.
So,
Any other value, Agatha?
so can I answer?
Yeah.
4. Oh, no. It's okay.
Yeah, say. Maybe it's correct. Say na. I'm listening.
Then I was thinking something else.
Like David says 4 comma minus 2. Like x is equals to 4 and y
Yeah.
is equals to
So I
minus
was
2.
going to say that, but it's x plus y, that's right. So it's x plus y, right?
So you took y as minus 2, na? Y is plus already. You took the value.
Okay.
Yeah. Agatha, any other value that you're thinking about?
X is equal to 3 and y is equal to minus 1.
X is equals to 3 and y is equals to minus 1. Correct? Any other value?
So 6 comma minus 4.
6. So like this, there are infinite number of solutions will be there. Because any number you can think, and the in contrast, if you will take the second number, then you will get the same value. So because it is 2 variable, because it's a linear equation in 2 variable, then how many solutions or how many answers will be there? Infinite. Stay with me. Infinite number of solution will be there. Okay. So linear equation
So,
in, yes.
so like x plus y equals to 2. So we can write 4 minus 2 also. Like minus can be also there.
Yeah, you can. No problem in minus or plus sign. Okay. Did you understand? Agatha, David? So the linear equation in 2 variable, how many linear equation in 2 variable, how many solutions will be there? Infinite number of solutions. Say with me, infinite number of solutions will be there. Okay, and linear equation in 1 variable, how many solutions will be there? Only one solution is there, not more than one solution. Agatha, David, did you understand? Now put a heading graph. Put a heading graph. Quickly. Yeah, is graph is there? Let me check. Graph is there. Yes, graph is there. So put a heading graph. Quickly. Now listen, guys. This is important part, and you have to make a lot of graph. So please pay attention in this. Abraham, are you there? Can you hear me?
Yes, sir.
Yeah. So this graph is very important because it's totally a new concept. So you have to pay attention in this. Okay. Agatha, you know how to make graph?
Yeah.
Okay. Very good. Okay. Now, first of all, the graph. Graph has four axes. Repeat after me. It has how many axes? Four axes.
Four
Okay. So,
axes.
for example, if I will write like this, there are four axes. Are there. The horizontal line is called as x-axis, and the vertical line is called as the y-axis. Horizontal line is called as x-axis, and the vertical line is called as y-axis. Understood, everyone? Obeyed? Still any problem? X-axis is also called as abscissa. Abscissa. And y-axis is called as ordinate. Y-axis is called as ordinate. Where the x-axis and y-axis are meeting, they are called as origin. The point where they are meeting, it is called as origin. Are you getting this? Say yes or no. The meeting point of x and y is called as origin. Now, listen, guys. Now, this y-axis, like because of this x-axis, it is divided into two parts: the above y-axis and the below y-axis. So the above y-axis is called as positive y-axis. It is called as positive y-axis, like +1, +2, +3, +4, +5, and then +6. Like this, it will go up. Okay. Now below y-axis, it is called as negative y-axis, -2, -3, -4, -5, then -6, and then 0. This is called as -y. Are you getting this? Say yes or no? In the same way, the right side of the y-axis, it is called as plus x-axis. 1, 2, 3, 4, 5, 6. Abraham, turn on your camera. 7, 8. Okay. And the left of the x-axis is called as negative x-axis. -1, -2, -3, -4, -5, and then -6 and so on. Okay, everyone got this? Yes or no? Okay. Now listen, everyone. So this is called as the first quadrant. Quadrant means four equal parts. So you can see this is called as first quadrant. This is called as second quadrant. This is called as third quadrant. And this is called as fourth quadrant. Quadrant means parts. Like first part, second part, third part, fourth part. That you have to remember. Everyone got this? Say yes or no? Yes or no? Still any problem? Done? Shall I raise this? Abraham, are you there? Abraham, can you hear me? Are you there?
Yes, sir. I had to go.
Yeah, turn on your camera. Are you able to understand all the things that I discussed today?
Yeah, I'm understanding, sir.
Yeah, very good.
I've done this before, sir.
Yeah, very good. Done? Shall I raise this? You want me to wait for 1 minute? What? Okay. Now listen, guys. How to mark a point? If a point is here, how to mark? How to write the address? How to write the address? So, for example, now listen, guys. Like for example, if I will mark a point here, if I will mark a point here. So first of all, we have to compare it from x-axis, and then we have to compare it from the y-axis. So if I will compare it from x-axis, if I will check it, I am getting the value on -2. On x-axis, it's -2, and on y-axis, it is on 3. Yes or no? Are you getting this? Say yes or no? On x-axis, it is coming at -2. On y-axis, it is coming at 3. And if you want to write the address of this, if you want to write the address of it, so first, every time you have to write this in the form of x comma y. Repeat after me. In the form of x comma y. Means the first x value will come and the second y value will come. So in this, if I will take this, on x it is -2, on y it is 3. So what is the address of this? It will be -2 comma. Everyone got this? No. Remember this thing, you guys don't have to make this line again and again. For the reference, you will make it with a pencil, and then when you will get it, just erase it. Are you getting this? Yes or no? Obey. Every time, first you have to mark the x-axis, and then you have to mark the y-axis. Abraham, got it? Abraham?
Yes, sir. Got it.
So what is exactly like for what type of sums?
Sorry, say it again.
Like for what types of sums do you use this for?
Sums is for making a graph. I am helping you guys to make a graph. And how will you make the graph? First, you have to know that how to mark the address if there is any point on the graph. For example, if I will make this point here, if I will make this point, so what is the address of this point? You have to mark it. And how will you mark it? First, you have to take a reference from x-axis. So I will take a reference from x-axis, and I got that it is on 6. And the second is I have to take the reference from the y-axis. And when I mark it, I got that it is on the 3. So how will you write the address of this point? It will be 6 comma 3. Means first x will come and then y will come, which is 6 comma. This is how you get the point. If there is any point on the graph, that how will you address it? This is it. Got it? Yes or no? Obit, got it? Okay. Now we'll do one more question. Okay, who will tell me the answer of this? Nayantara, can you please tell me the point? Oi. Yes, Nayantara. Can you please tell me the point of this? What is the answer of this? Yes. 3 points.
Yeah, it is x is to y, which would be 4 comma minus 4 comma minus 5.
Okay, so first we will compare it from the x-axis. It is -4, not 4. Okay, you have to take the sign out. Are you getting this? Say yes or no? And then we have to take the y-axis, which is 6, -6. Okay, so what is the address of this? Which will be -4 comma -6. Nayantara, you got it? Yes or no? Okay, M for Miracle. Can you mark the point M? What is the address of this Miracle?
5 comma minus 5. No.
5 comma -4. 5 comma -4. Very good. Okay, Abraham, A for Abraham. Can you mark this address, please?
So can you repeat, sir?
A for Abraham. Can you mark this point A? What is the address of point A? Wait. अरे क्यों? Just give me a second. My tab got disconnected.
Oh, presentation anymore. So I can't see your presentation anymore.
I know. My tab got disconnected with Wi-Fi. Come on. Just give me a second. Yeah. So okay, Abraham. Can you tell me the address of this point, please? So on x-axis, what is the number?
So
Tell me, Abraham.
0, 4.
0, comma.
0, 4. Minus
0,
4. 0
comma.
minus
Yeah.
0,
Very good.
comma
0,
minus
comma
4.
minus 4. Very good, Abraham. Everyone, please remember this. The point of this origin, the coordinates of this origin is 0, comma 0. Because on x-axis is also 0 and y-axis is also 0. So hence it is called as 0, comma 0. Are you getting this? Yes or no? Now I will give this chance to Agatha. Agatha, can you mark a point which have coordinates -4, comma 6? Can you mark a coordinates which has point -4, comma 6? You have pencil in front of you. Just click it and mark where it will come. Roughly, it will okay. No problem. Don't make lines. Okay, just make a point. Yes.
-4, right?
Yeah, I wrote the point on the board. Can you check that?
Right. Yeah, I can see
Yes.
it.
Yeah.
Yeah. Okay. Okay, wait. Wait. Yeah. 6. This should be the approximate point. Sir,
Yes, beta.
is this the point?
-4, comma 6. Very good. Very good. Abhay. Yes. Okay, I will give this chance to Nayantara. Nayantara, can you mark a point 0? Okay. Not 0. You make 4, comma 0. Yes. Yes, Nayantara. Can you mark this? So remember this thing. The first is always x and the second one is always y. So x, you go to the fourth, okay, and y is 0. So where will be the answer? The answer will be here. Okay, Nayantara? Got it? Hmm? This will be the point of, this is the point of uh, 4, comma 0. Miracle, did you understand? First of all, you have to go to the x, then you have to check the y, x and y. Like this, you have to go. Got it? Say yes or no?
Yes.
Okay. Okay, I will give one more thing. Okay. Tell me the answer of this. Who will tell? Abraham. Oh, it's okay. Nayantara, can you tell me the answer of this? This point.
Which point, sir?
This point.
Okay. 5, 3.
Very good. 5 points. Got it, everyone? Say yes or no. Everyone got it? Now, after this class, I will send you the worksheet that you have to make the graph and you have to mark the point and you have to send it to me. Okay. Here are the points. Agatha, here are the points. You have to make the graph and you have to make the just put a point and then you have to send it. Okay. So the points are, you guys quickly write it down. And only one graph is needed for all the points. Okay. Not 1.1 graph. It's not like that. Only one graph for all the points which I'm giving. Are you getting this? Say yes or no?
Sir, shall I also send this in the group?
Yes. Huh. Everyone got this homework? Yes, say yes or no?
So do we just put a point over there, or do we have to draw a line to it?
No, no, only point. Where it is lying, just point it and mark it as A, B, C, D like that. Okay, done. Done, everyone understood? Miracle, did you understand? Abraham, now you guys have 2 minutes break. Come back, we'll start our science.
Okay, so that's a homework, right?
And that's our
This
homework.
is which exercise?
Sorry?
Is this like an exercise?
Yeah, this is a homework. You have to make the graph and you have to mark all the points on it. Got it? Okay?
Okay, so this is there in the textbook.
No, it's not there in test.
Okay, okay.
But the next topic which is coming, it's related to that only. That's why I am giving it.
So I have a question, sir.
Please wait up.
So when is our break gonna start?
Our break will start in June.
So can you repeat in June?
Yeah, in June.
Okay, sir.
So, sir, about that, in May, will there be class?
So why
Yeah,
not in May, sir?
yeah, because May I don't have any holidays. Like June is the holiday month for me. Because June I usually take holiday.
The
Okay?
last one, the 10th one, is that 1, 2 or 6, 2?
6 comma.
So,
Now
sir,
come back
like
in.
June
Yeah.
1st, there is
Say it again.
from June 1, the break will be starting.
Yeah, from June 1 to June 30. Okay? Okay, come back in 2 minutes. Come back.
So, so
Yeah.
I won't be able to join class on Thursday and Friday. So I have a summer camp. So is that okay?
Okay, okay. No
Thank
problem.
you.
Okay, bye, sir. Thank you.
Bye, bud.
Okay, guys, come back. No way. Okay, guys. So, what we were doing? We were doing a new chapter. Hello, Nidhi. Okay. So, what we were doing, guys? Yeah. Haha. Like my age is now becoming very old. Like I'm getting old. So that's why I'm forgetting the thing.
Chapter 5
So
atomic.
sorry.
Chapter 5 atomic.
Yeah. Huh? Yeah. Atomic structure. We have to learn the atomic structure. Okay. So we did the discovery of neutron. Yes or no? Now everyone turn on your camera, please. David, Miracle, and Nidhi. Yes, I can hear you, beta. It's crystal clear. Yes, beta.
Okay. Yeah, my computer was not
Okay.
responding. I couldn't say
Uh,
anything.
okay. Abraham, David, turn on your camera. I know. Yes. Okay. So now today we will learn about the. Now listen, guys. We like we know electron, proton, and neutron, and even now the scientists, because of their experiment, they also know the electron, proton, and neutron. But now, how the electrons, protons, and neutrons are arranged? Repeat after me. How the electrons, protons, neutrons are arranged? It's that point. Okay, like the electrons, neutrons, and protons, how they are arranged, that is the main point. How, like for example, if I will come to uh, Joshua house, okay. So in starting, when I will enter in it, okay. So basically, the normal houses have drawing room like sofas and TVs and everything. Okay. But if I will come and in the drawing room, Joshua has all the kitchen stuff. How will it look like? Hmm?
Strange, weird, whatever. Something like
It's strange. It's weird. So that is like arrangement of the inside the atom is necessary. Arrangement inside the atom is necessary so that we can predict the nature of the atom. Are you getting this? Say yes or no. Hmm? Means how the atoms are arranged, we don't know. Now the scientists also don't know. Now they are doing some. They are some giving some theory. They are giving some hypothesis. They are giving some ideas that no, the atom can be arranged like this. They are doing some experiment to get the theory. So these all we are gonna learn. Are you getting this? Say yes or no. Hmm? So
yes.
first is again Johnson baby. I mean J.J. Thomson. He discovered the first model. Like he gave the first model, and the first model is Thomson model. Okay, and if you have books, so you can write it down like this also. It is also called as watermelon model. Watermelon.
Called
Or
the pudding
sometimes it is
model.
called as, yes, sometimes it is also called as plum pudding model. Sometimes it is called as watermelon, sometimes it's called as plum pudding. Now, what does this mean? Now, listen, guys. In watermelon or plum pudding model, what's the catch in this? He said, like a watermelon. Everyone knows watermelon. Everyone eats watermelon. Now, how watermelon look like? Watermelon is basically red in inside color, and the black seeds are there, which is embedded in the red color. So he also gave the same logic. He said that like a watermelon, the red part is called as the proton. Okay, you can see this diagram also. Okay, you can see the diagram also. The red part is basically the proton, and like seeds are embedded in the red part, na? In the same way, in electrons are embedded in the red part. Are you getting this? Yes or no? This is what he says. He says that the red part is the proton part, and the electrons are the seeds,
I
which
have
like
a
in the watermelon, and it
question.
is embedded. Let me complete it, beta. Okay, let me complete. Then I will ask. So the red part is the proton part, and the black seeds part are called the electron, which are embedded in the this thing, proton, the red flesh part. Are you getting this? Say yes or no. Now, Ibrahim, ask me,
Yes, sir.
beta.
So my question is that so in my other textbooks, so it's normally referred to as the cookie cutter model. Why is it called the watermelon?
Cookie kara.
Yes, sir.
Wow.
In my textbook, it says like in an IGCSE science textbook I was reading, it says that the
Hmm.
entire thing is the cookie, and the electrons are like the chocolate chips on the
Choco
cookie.
chips. Acha, cookie. Okay, okay. Yeah, that same like plum pudding, no? Like the entire thing is like the cake, and you know the cherry on the top, huh? So in if you will eat the pudding part, so in that there is a cherry is embedded in it. Cherry is embedded in it. So that is called as electrons. So like it's like that only. So in some it is all called as watermelon. Sometimes in some books it is called as plum pudding. So it's like that only. Got it, Abraham? Yes or no?
Okay, okay, sir.
Okay. Are you getting this? So now this theory got
Yes.
rejected. He gave the theory in which saying the positive part is proton and the negative part is electrons and like that. But this got rejected. The reason behind it, okay, the reason behind it is positive and negative part, if they are attached to them, this make the atom unstable. Like here it is what is saying, the electrons are embedded in the positive part, means they are touching each other, and if they are touching each other, it makes an instability in the atom. Are you getting this? Huh? Instability means you are sitting and your table get bombarded, boom boom boom, automatically. Everything is bomb. You're eating a apple, and in apple bomb, it's like that. Huh? But the reality is not like that. Okay, so that is why Thomson model get rejected because of their instability. Are you getting this? Are you getting this? Say yes or no? Okay. Okay, who will read this? Joshua will read this. Joshua, please read this. Can you read this from Joshua?
In lesson 3, you have learned that all matter is made of atoms and all the atoms are electrically neutral. Having discovered electron as a constant of atom, Thomson concluded that there must be an equal amount of positive charge present in an atom. On this basis, he proposed a model of the structure of an atom. According to his model, atoms can be considered as a large sphere of uniform positive charge with a number of small negatively charged electrons scattered throughout it. Figure 5.4. This model was called the plum pudding model. The
Yeah.
electrons represent the plums in the pudding made of negative charge. This model is similar to the watermelon, in which the pulp represents a positive charge and the seed detonate the electrons. However, sir, however, you may know that a watermelon has large number of seeds, whereas an atom may have not as many electrons.
Correct. Correct. Everyone got this? Now we will read the next model, which is called as Rutherford. Now, like if you will check about the in plum pudding model or the watermelon model, these are not the any experiment they did and they find it out. No, okay, they are just simply giving the what they have imagined. Okay, but Rutherford is a proper experimental guy. He did experiment and then he gave some conclusion. Okay, that is called as Rutherford model. Are you getting this? Hmm? The watermelon medal or the plum pudding medal, they are just hypothetically part. Means they are not giving the perfect answer of it. Are you getting this? Say yes or no.
Yes, sir.
Okay. So now how it's giving. So we'll check it out. Listen, guys. So in Rutherford model, what Rutherford did. Now listen, please listen. So what Rutherford did. Rutherford took a golden foil. Which foil? Golden foil. Okay. And he took one source body, which is the source of alpha particles. It is a source of alpha particle. Now, what is alpha particle? Remember this thing. So, alpha particles are basically made up of helium. Alpha particles are made up of helium. It has 2 electrons and 2 protons. Helium has 2 electrons and 2 protons. But they are little bit different. What is the different in this? That the 2 electrons that they have, when you will remove it, then it is called as alpha particles. Are you getting this? Yes or no? Like if I will talk about 2 electrons and 2 protons, what is the charge on an atom? 0, because plus 2 minus 2 becomes 0. Are you getting this, Miraculin? If I will remove the minus 2 charge, what is the charge on the atom now? Only plus charge is there. So what is the alpha particle charge? Alpha particle charge has plus 2. Are you getting this? No.
No, sir.
See, alpha particle is basically made up of helium. Alpha particle is nothing but made up of helium. Okay, it's made up of helium, and helium usually has 2 electrons and 2 protons. Okay, but this helium particle is different. What is different in this? That the 2 electrons that they have, it's not there. 2 electrons are not there, and it's make the alpha particle. So alpha particle charge will be plus 2 because only positive charge is left. Are you getting this? Yes or no? Now what he took this gold foil. This is what? This is gold foil, a thin gold foil. And then he took a screen. He took a screen like this. Okay. And then he bombarded this alpha particle from this machine. And when he bombarded it, he got some results like this. Like this. Some of the rays got straight like this. Some of the rays got straight. Some of the rays is deviated with some angle, and 1 out of 12,000 got repeated on the same path. I am repeating this. He did this experiment, and in this experiment he got something. What he got? He got that some rays go straight. Some rays got deviated like this. And 1 out of 12,000 it got reflected back to the same path. Are you getting this? Yes or no? So now first of all, what we have to understand in this, that alpha particle is a positively charged particle, positively charged helium atom. And what is the charge on it, Nidhi? What is the charge on alpha particle?
I don't know.
What is the charge on alpha particle? Like 2 electrons are there and 2 protons are there. 2 electron denotes minus 2. 2 proton denotes plus 2. And what is the new thing in the alpha particle is that the negative charge, like minus 2 charge, is removed. Now what is remain behind?
Plus 2 protons.
So what is the charge? What is the charge on alpha particle? Plus 2.
+2.
Okay, so the charge on alpha particle is +2, and he saw this result. So for example, if I will make an atom, like this, okay, so this is the alpha particle that is bombarded. So what happened in this, that some of the particles get like without deviation, they go in a straight line. Okay, some of the alpha particle, they go in a straight line. Now everyone please pay attention. Some of the particles, it got deviated by some angle like this. Are you getting this? And 1 out of 12,000 particle got in the same path, like from where it is coming, the same path it took, like it retraces on 180 degree. Are you getting this? So from this, what he gave, what he's deviated, what he conclude, he conclude that most of the atoms are empty space. That is why there is no deviation in this. Can you see this? They are going in straight line. No? There is no deviation because most of the atoms is what? Empty. Are you getting this? Yes or no? Okay. The first point is most of the atom space is empty. Second, he says that, see, now I told you this is the positive charge particle. Just now I told you that alpha particle is positively charged, and when the alpha particle is going from the nucleus, it is getting deviation. It means that the nucleus also have positive charge. That's why it is getting deviation. No? If the nucleus has negative charge, then it won't deviate. Like positive repulse. Like north pole repulse na in a magnet. North pole and north pole repulse. In the same way, positive and positive repulse. So he conclude that the mass. This is the mass
Sir,
of an, yes.
so I'm just going to get a charger, sir.
Okay. The nucleus is the, like he gave the name nucleus also. He said that nucleus found in the center of the atom. Nucleus is found at the center of the atom. It has all of the mass of an atom, and it has positive charge particle. It has positively charged particle. And what is the positive charge particle in the atom? It is proton. So he says that in the atom, in the center of the atom, proton is present. Are you getting this? Any problem till now? Ask me. So first he says that Abraham, what is the first conclusion he made? Can you repeat? What is the first conclusion he made? Abraham. Unmute your mic. Abraham, can you hear me? Is it he's
Abraham?
getting voice?
I think it's disconnected audio.
Okay. Okay, so what is the first conclusion, Miracle? That most of the space in an atom, yes,
Yeah, most of the space in the atom
is empty. Like there is nothing is there. Okay, it is empty. The second conclusion he made is the center of the atom has a mass and name it as nucleus. Like all the mass of the atom is concentrated in the nucleus. Are you getting this? And nucleus have positively charged particle named as proton. He made three conclusions. Are you getting this? Say yes or no, Nidhi.
The first conclusion I didn't understand.
Like if it is as mass, for example, if I will put something in his, so obviously whatever the thing which is coming, it will get deviation in that place also, na? But here it is no deviation in it. No deviation in it means that it nothing is there and is going straight. I now got it.
Okay.
So, where there is no mass, there's empty free space.
Yeah, free space. That is why it is going in a straight line. There is no deviation in it.
Okay.
Yes, Agatha, better.
Yeah, I repeat.
Sir, aren't electrons?
Sorry. One by one.
Aren't there electrons in this model?
See, the electrons are there, but if you have read before also, electron mass is very, very less. It's negligible. In the book is also written as negligible. So that is why it is say like that is why saying now that all the mass of the atom is in the nucleus. That is why deviation is happening when the ray is going from the center of the atom.
So the
Because
ray
the
will
protons
just
has
pass. Yeah.
say it again.
So the rays just pass through the electron.
Yeah, it passes through the electron because the electron mass is negligible, 0. So that is why it concluded that there is no deviation in it because it's empty. And the electrons, like if I will talk about the electrons, we'll read in the further part also. The electrons are revolving around the nucleus. The electrons are revolving around the nucleus, and it's not that all the electrons on one side or all the electrons on this side or all the electrons on this side. It's not like that. It's like a solar system. Sun and the planets are revolving around the nucleus, na? Around the sun. Na? In the same way. We're going to learn that. Till here, any problem, guys? Abraham, do you have any problem? Now you can hear me better?
Can you repeat the three conclusions? The first was the most of the space between the atom. The second
Yeah,
was
most of the space is empty. The center part is called as the nucleus, and all the mass of the atom is concentrated in the nucleus. All the mass of an atom is concentrated in the nucleus. And the third point is nucleus has positively charged subatomic particle named as proton. Are you getting this? Yes, Nidhi.
So the first conclusion was most of the space in space is empty. And then second, nucleus is the mass of an atom.
Nucleus concentrate all the mass of an atom.
Okay.
Nucleus concentrate all the mass of the atom, and it is found in the center of the atom. And the third is that in nucleus there is a positively charged particle called as proton. That is why there is 180-degree deviation in it, like this. Because positive repulse, na, that is why.
Yeah, the person who found this
Is this is we're gonna learn. We're gonna read this.
Okay.
Yeah. Who will read? David will read. Yes, David, please read this.
Rutherford's model. Ernest Rutherford and his co-workers were working in the area of radioactivity. They were studying the effect of alpha particles on matter. The alpha particles are helium nuclei, which can be obtained by the removal of 2 electrons from the
Remember,
helium
underline
atom.
this. Underline this because they can ask you in this part. They will ask you in the this part. Abraham, please pay attention on the board, on the class.
Yes, sir.
Don't see here and there.
In 1910,
Okay.
Hans Geiger, Rutherford's technician, and Ernest Marsden, Rutherford's student, performed the famous alpha ray scattering experiment. This led to the failure of Thomson's model of an atom. Let us learn about this experiment.
Yeah, we'll read this. Read it.
Alpha ray scattering experiment.
Yeah, read.
In this experiment, a stream of alpha particles from a radioactive source was directed on a thin, about 0.00004 centimeter thick piece of gold foil. On the basis of Thomson's model, It was expected that the alpha particles would just pass straight through the
Pass through.
gold foil and could be detected by a photographic plate placed behind the foil. However, the actual results of the experiment were quite surprising. It was observed that most of the alpha particles passed straight through the gold foil.
Now, this
Some
is the important thing. You guys have to mention all these things. Like if they will ask you, what do you mean by Rutherford model and what are the observation they got? These are the observation. Like most of the alpha particles pass straight through the gold foil. Second is some got deflected by small angle. A few get with a large angle. And the third one is that experience a rebound. Rebound means when it go on that direction, it will coming from that same direction. Yes, Nitu. Yes, Nidhi. You're mute.
Yeah. The alpha particles are helium.
Helium without electrons.
Yeah. Okay. So
Okay, helium.
the last few models we checked didn't have electrons, right?
Which experiment, beta?
And the last few experiments, like electrons were minus. It was not there.
Which experiment you're talking about?
The last one we did right now.
Yeah, that's the same experiment we are reading from the book.
Okay.
It's the same experiment. We are not doing anything new. The what I taught you just now, we are just reading it from the book.
Okay.
Okay. Yeah. So now basically what he concluded and he proposed some theory out of it. Yes, Abraham, can you read this?
An atom contains a dense positively charged region located at its center. It is called as nucleus. All the positive charge of an atom and most of its mass is contained in the nucleus. The rest of the atom is the empty space which contains the much smaller and negatively charged electrons.
Yeah, you can see this diagram. This diagram is also one of the important diagram. You can mark it as important, put a star mark in this. Like if they will ask you in 6 marks question, what is the Rutherford theorem and what is what he gave, you have to make the diagram. You have to make what he observed, how he performed it, what is the conclusion he made. And you have to make the proper diagram like that. Then only you will get the 6 marks or 5 marks. Are you getting this? Say yes or no? Everyone got it? Say yes or no?
Yes, sir.
Yes, sir.
Okay.
So which one did you say is the important diagram?
This question, if it will come, that what is Newman Rutherford experiment and why it is important like that.
I think David asked which diagram. There is 2 diagrams, right?
A diagram you say. 99, page number 5.6 and 5.5, both are important.
Okay, sir.
This is the glitch I'm facing. Why? I don't know. Okay. Now read this, Abraham. Abraham, are you there?
Yes, sir. On the basis of the proposed model, the experimental observations of the scattering experiment could be explained. The illustrated figure 5.6d, the X particles passing through the atom in the region of the electrons will pass straight without any deflection. Only those particles that come very close in the vicinity of the positively charged nucleus gets deviated from their path. Very few alpha particles, those that collide with the nucleus, would face a rebound.
Yeah. So
On the basis of
basically,
this
these.
model, Rutherford
Yeah.
was able to predict the size of the nucleus. He estimated
Hmm.
that the radius of the nucleus was 1 with 4 zeros times smaller than the radius of the atom. We can imagine the size of the nucleus with the following analogy. The size of an atom is a cricket stadium, and the nucleus would be the size of a fly of the stadium. So,
Center of the stadium. Like for example, you guys who follow football or a cricket match or the basketball. So in the basketball or like it's a cricket stadium, it's very huge. Or it's a basketball, sorry, football stadium, it is very huge. Okay. So if any house fly is there in the stadium, so the stadium represent the atom, and the house fly represent the nucleus. It's like that ratio. Are you getting this? Yes, Abraham, you were saying something, beta. Abraham, you were saying something?
no, sir.
Okay. So now this theory, now this is the homework. Agatha, please put in the group. This is the homework. Yes, Nidhi, beta.
Yeah. So my question is here that it's written he established that the radius of nucleus was at least 1 by 10,000 or something. So what is this exactly? Like when we understand it,
He predicted like that how if I'll compare a size of an atom and size of a nucleus, then you will get that it is 1,000 times smaller than the size of an atom. And then he compared it with the example of stadium and a house fly. So if in a stadium, in a big stadium like cricket stadium or football stadium, a small housefly is, if it is roaming in the center of the stadium, that much ratio is there in which the housefly is like a atom. So it is like a nucleus, and the stadium represent the atom. That much comparison he took, like 1,000, 1/10,000 times.
okay.
Okay.
And when we write notes, should we write this also?
Yes, sure.
Okay.
Yeah. Yes, Agatha.
So, sir, so the number of electrons and protons in an atom is quite less if they have to be equal.
No, not necessary. Like protons are there inside the nucleus. So if atom is big, obviously, like for example, if atom is 1 kilometer and the nucleus is 1 centimeter, if it will become 2 kilometer, then nucleus will become 2 centimeter. If the atom will become 4 kilometer, then nucleus will become 4 centimeter. So the ratio will be doing such way that it is dependent on the size of the nucleus atom also. If atom size will increase, obviously the size of the nucleus will also increase. So protons number can easily fit into it. Are you getting this?
Yeah.
Okay. For example, if hydrogen has only one proton, the size of the atom is very small. That is why the size of the nucleus is also small. That is why only one proton can come into it. But if I will talk about the cesium, the cesium size of atom is very big. So that is why the nucleus is also very big. That is why the number of protons can come. It's not only one. It can come around 67 or 18, 80. Are you getting this? This is the way. Okay. Now we'll learn about that why the Rutherford model got drawbacks. So Abraham read this, na? Abraham, can you tell me why it got rejected by the scientist? Do you have any idea?
So, can you repeat, sir?
Do you have any idea that why the Rutherford model get rejected by the scientist?
So, why Rutherford's model got rejected by scientists?
Yeah.
So, can I say why, sir?
Yeah, I'm asking from you only. Yes.
Because so he never knew that neutrons existed.
He never knew that neutrons existed. I guess by that time Newton get discovered also. I have to check the
Also,
timeline. Yeah.
also another thing is that his models got rejected is because I think because the electron doesn't just spiral into the nucleus. That means the electron will slowly converge into the nucleus. So, if you see the
Okay.
diagram 5.7.
Yeah, that is correct, but not the perfect reason I'm getting. Okay, Agatha knows. Yes, Agatha, do you have any idea?
Well, the same thing, but except something with energy, it is written something like we know an atom is stable and such a collision will not appear. And not just that, when the electron keeps like revolving around the atom, there's something like a lot of energy would be released, making an atom unstable and finally it will fall to the nucleus.
Okay, it's like this. I'll tell you the reason. David, you want to give a try quickly? 1 minute try.
I was saying that the it is wrong because the alpha particle, like, instead, according to Rutherford's model, according the alpha particles would have, like, wait one second. According
Alpha
to
particle is? Yeah. Say it again, beta.
It's no, it's okay.
Okay. So the thing is, he told us, like Rutherford told us, that inside the nucleus, protons are there. Now, scientists ask, where are the electrons? So he said that electrons usually revolve around the protons, means nucleus. Electrons are revolve around the nucleus. He's told it like this. Now, there is one more scientist that was there. His theory was proven. Now, the electrons are revolving around the nucleus is just given by the Rutherford. There is no experiment in that. So one more scientist was there. His name is His name is Broglie. D. Broglie, I guess. So D. Broglie says that when an atom moves, it radiates energy. It radiates energy. Okay. When any particle will move, it will radiate energy. Now, what Rutherford says that electron revolve around the nucleus. If electrons revolve around the nucleus, so it is moving, and if it is moving, it will radiate energy. Electron will lose energy, and if electron will lose energy, it will make a spiral form. It will make the radius slow, and at some time, after some time, it will go and it will fall in the nucleus. Again, the positive charge and negative charge, they are mixing up, hence the blast will happen. So Rutherford says that it revolves around the nucleus. This is the drawback or the rejection of the Rutherford's model. Okay, he cannot explain the stability of an atom if electrons are revolving around the nucleus. Are you getting this, everyone? Yes, Nidhi.
So sir, what was the question? I didn't understand the questions also.
The question was why the Rutherford did experiment, his theory get rejected. That's the question.
Okay.
So the answer of that is that he said that electrons revolve around the nucleus. That is the rejection. Why? Because if it is moving, it will have the this thing. It will radiate energy and it will lose the energy, according to the D. Broglie. Okay, according to D. Broglie, it will lose the energy and it will stop at time, and it will go and it will collide it with the nucleus as you can see in the diagram. Are you getting this? Okay, so if it is go and it will collide it with the nucleus which has positive charge, negative and positive charge, they are colliding, hence blast will happen. So this is basically the rejection. So atom does not blast, they are stable. So it means that electrons are not falling into the nucleus. Yes, Nidhi.
Sir, like you asked if were able to understand this concept. I'm not able to understand. So
See, the question is why Rutherford theory get rejected? Simple as that. Why? So Rutherford says that electrons revolve around the nucleus. Like he discovered the proton, he discovered the nucleus. He said that protons are inside the nucleus. Simple as that. Okay. Now, what about the electrons? Where are the electrons? So he said that electrons revolve around the nucleus. Simple as that. If electrons revolve around the nucleus, if electrons move around the nucleus, it will radiate energy. And if it will radiate energy, it will lose energy. And if it will lose energy, it will fall into the nucleus after some time because there is no energy. If there is no energy, the positive and negative charge they will attract now. They will the electrons like moving and moving and moving. After some time, it will fall into the positive charge, and positive and negative charge they will collide, and the blast will happen. Okay. So Rutherford did not able to explain this. That is the rejection of this theory. Got it, Nidhi? Now,
yes, yes, sir.
okay. So we'll read this. Who will read? Joshua will read this. Yes, Joshua.
According to Rutherford's model, the negatively charged electrons revolve in a circular orbit around the positively charged nucleus. However, according to Maxwell's electromagnetic theory, about which we may learn in higher classes, if a charged particle accelerates around another charged particle, then it will continuously slow down and lose energy in the form of radiation. The loss of energy will slow down the speed of the electron. Therefore, the electron is expected to move in a spiral fashion around the nucleus and eventually fall into the atom as shown in figure 0.7. In other words, the atom will not be stable. However, we know that the atom is stable and such a collapse could not occur. Thus, Rutherford's model is unable to explain the stability of an atom. You know that an atom may contain a number of electrons. The Rutherford model also does not say anything about the way electrons are distributed around the nucleus. Another drawback of Rutherford's model was its inability to explain the.
I'm not able to change it. So basically, the conclusion of this paragraph is he's not able to explain the arrangement of electrons. He's not able to explain the movement of electrons or how the electrons are arranged. Simple as that. Are you getting this now? Anybody's any doubt?
No, sir.
No? Okay. So we'll end this, and tomorrow we'll learn about the Niels Bohr atoms theory. Niels Bohr atom theory that we are following till now. Means that was a successful given by the Niels Bohr. Are you getting this, Nidhi?
Yes, sir. Yes, sir.
Okay. So we'll end this. You guys have to do this homework. Agatha, please put a message
Sir,
of this. Yes, beta.
I have a few notes to finish the remaining chapters, like the two chapters. I couldn't finish it. Try my best to finish it.
So you finished it and you have to send me the homework also.
Yeah, I'll for now I'll write it in another page and answer these
Sure.
questions, and after that I will put it in my official
Yeah.
note.
Please, this is very good move that you are doing your notes sincerely. Like it's that is the basically drawbacks of online teaching. Like I'm not able to see your notes and like homework I'm seeing it, but the notes part I'm not able to see it. But it is your responsibility, guys. Faithfully, you have to do your this thing, the notes part and everything, complete it, so that it will help in your exam only. So it's very good move. Okay. So we'll end this class. I hope you have enjoyed the class. Till then, bye. Have a nice day. Signing off. Tabashabake. Sayonara. Bye bye.
Bye, sir.
Meet
Thank you.
Bye,
tomorrow.
sir. Thank you
Bye,
so much.
bye, David.
Thank you.
Bye, sir.
Bye.